Welcome to 7.6. It's solving inequalities using addition or subtraction. Your essential question for the section is, how can you use addition or subtraction to solve an inequality? To start this section off, we have our key ideas, and the first one is the addition property of inequality, and the next one is the subtraction property of inequality. I'm going to explain to you what this is in words and then in numbers like usual, and then I'm going to do a comparison for you of how an inequality is very much like an equation. So here we go. So in words, it means when you add the same number to each side of an inequality, the inequality remains true. In numbers, it looks like this. If I had 3 is less than 5, and I added 2, whoops, I'm going to actually erase that and change my color on it. But if I were to add 2 to that, and I would get 5 over here, if I added 2 on this side, because whatever you do on this side of the inequality, you have to do on this side, just like with the equations. 5 plus 2 is 7. My symbol of less than stays the same, so 5 plus 2 is 7. It still holds true. 5 is less than 7. So yes, it does work. When we're talking about algebra, it's going to look very similar. So x minus 4 is greater than 5. Hang on. Then we look at it just like we would with an equation, and we want to get x all by itself, so I'm going to add 4, because I know negative 4 plus 4 gives me 0. Okay, and again, you don't have to write that 0 down there. We know that it gets rid of each other. We're just left with x. We keep our same inequality symbol. Whoops. Okay, keep the same one. And then I'm also going to add 4 over to this side, because I did it over here. I have to do it over here. So 5 plus 4 is 9. So that's telling us that x is greater than 9. Because we've solved it as far as possible, we could graph this. And it's very simple. All we do is put our 9. It's got to be an open circle because we don't have the is equal to sign. And then what does it tell us? It's telling us, let me just get these plotted real quick, 8, 7, and 6. So it's telling us that x is greater than 9. That means it's anything larger than 9 would work. Okay. If I were to plug in these numbers just to test them out, let's say I use 7. Is 7 greater than 9? No, it's not. Let's try and plug in another one. What if I did 11? Is 11 greater than 9? Yeah, that does work. So I did extend my line in the correct direction. So the key idea to continue is the subtraction property of inequality. So basically it's the same thing as the addition, only we're subtracting. When you subtract the same number from each side of an inequality, the inequality remains true. So looking at this with numbers, if we had 3 is less than 5, and then we were to subtract away 2, over here it would be 1. We would keep the same inequality sign. And then we do the same thing over here. We subtract to 2. 5 minus 2 is 3. Is 1 less than 3? Yes. Is 3 less than 5? Yes. So it still remains true. Looking at it from algebra, we have x, let me change my color here, x plus 4 is greater than 5. So if we were to try to do the same thing we would with an equation, we want to get x all by itself. So I'm going to subtract out that 4, because that will get rid of it. Plus 4 minus 4 is 0. And that gives me x all by itself with the same inequality sign. And I'm going to do the same thing over here. I'm going to subtract out 4. 5 minus 4, and that gives me 1. So that changes a little bit. X is greater than 1 is what that's representing. And same thing, I can do a graph, because I can graph this right here. I can start with 1 down the middle. Just do a couple to add to my line graph. And then I start with my 1. I leave it open because it's not equal to. It's just greater than. And anything x is going to be greater than 1. So it's going to be going to the right. And you color it like this, but leave that circle open. So I just want to prove to you how this is exactly like what we did in 7.2 and 7.3 by showing you an equation versus an inequality. It's very simple. I'm going to give you the same problems, only one's an equation, one's an inequality. Okay, so I've set up two different problems, but, well, kind of they're the same. You'll notice in my first one over here, I've got my equal sign with my equation, and over here I've got my inequality sign with my inequality. But all the numbers are the same, and we're going to solve it just the normal way we would. Now, on both of them, I want to get x by itself. So if I want to get x by itself on my equation, I'm going to take away the 4, because 4 minus 4 is 0. That gives me x by itself equals, then I'm going to do the same thing on this side and take the 4 away. 10 minus 4 gives me 6. So that's telling me that x equals 6. So I'm going to do the same thing over on this side, and I'm going to subtract out my 4. That gives me 0. So you're left with my x. I'm going to keep my inequality sign just like I kept my equal sign on the other side. And then I'm going to subtract 4 over here. 10 minus 4 gives me 6. So now I have x is greater than or equal to 6. Is that true? So if I were to graph this, I'm going to close my circle because it's got to be equal to, or it's got to be greater than. So I'm going to make my arrow go this way. So what I'm trying to say here is one of those numbers, the 6, the 7, the 8, or the 9, or even further on, have to be a solution for this inequality to be the same. That's the only difference between an equation and an inequality. So example 1 is solving an inequality using addition. My directions say solve x minus 3 is greater than 1, and it says graph the solution. So my first step is to write the inequality, and then I want to get x by itself. So I'm going to add 3 to this side, I'm going to add 3 to that side, because whatever I do here, I have to do here. So that gets rid of those, and it leaves me with x is greater than 1 plus 3 is 4, so x is greater than 4. Then all I'm doing is graphing my solution on a number line. Start with 4 in the middle. I can debate right now whether it's an open circle or it's a closed circle. Well, because it's not, I don't have a sign like that, so since I don't have it, it's open. I'm going to plot a few more numbers on here real quick. And then go in the direction that makes sense. So x is greater than 4, so it's got to be larger than 4. So that's telling me to go to the left, or I'm sorry, go to the right in my direction. So because I went to the right, now I just want to test it out just to make sure I'm correct. So I'm going to use the number 6. Is 6 greater than 4? Yes. Let's try 2. Is 2 greater than 4? No, it's not. So that does not work. So I tested out my theory here just to make sure, and yes, I went the correct direction. So example 2 is solving an inequality using subtraction. So they tell the directions say solve 15 is greater than or equal to 6 plus x, and then it says graph the solution. So we just rewrite out our inequality. So I have 15 is greater than or equal to 6 plus x. And again, I want to get x all by itself, so to do that I want to get rid of my 6. So I'm going to subtract 6 from this side. I'm also going to subtract 6 from this side. This gives me x all by itself. I leave my same inequality sign. And then 15 minus 6 gives me 9. So now I have 9 is greater than or equal to x. But when we're dealing with our number line, be careful because we usually write it the other way. This could be written like this, and you need to know how to flip-flop it. So 9 is greater than or equal to x. If we write x first, we flip-flop our sign the other way and then put it to 9. So 9 is greater than or equal to x. It also equals x is less than or equal to 9. We should be able to look at that and do that with any problem. We could have also written it like this, and we could have put x plus 6 is less than or equal to 15. That would have worked too, and I could have still done the same problem. Take away 6, and I would have been left with this as a solution. Because this is the proper way to do the graphing, you're going to have to recognize if your variable is not first, you need to make it first. Okay? So you might have to do a little bit of switching. The key factor here is, let me circle with blue so you see it, is switching the direction of our sign. Okay? The direction of our sign switches if you flip-flop the numbers. Then that just leads us into an easy graph, because we're saying not or x is less than or equal to 9. So it's a closed circle because it's equal to, and that means it needs to go this way because it's less than. And we want it to be a smaller number than what we started with. So our x is less than or equal to 9. Alright, here are your practice problems for the end. It's on your own on page 334 and 335. All 6 of them, you're doing the same directions. You're solving the inequality, and then you're graphing the solutions on a number line for each of them, just like we practiced. So make sure you're showing all your work, how I just showed you to set them up. And this concludes 7.6. Somebody's here to maybe say hi to you. Do you want to say hi?
Yeah.
What? That wasn't hi. I don't even know what that was.
Can you say hi to it?
Hi. Can you do it now?
No.
Why?
I don't want to.
Oh, are you cranky? Tell them what you just got done watching.
What?
What did you just get done watching?
The Ninja Turtles.
Ninja Turtles. Why do you have to whine when you say it?
I just want...
Okay, can you say bye? No, it's really hard, I know. It's tough being 3, isn't it? Yeah, he shook his head. Alright, signing off. See you tomorrow. Okay, he's coming back to write on the next page. Here you go. You're going to draw the picture?
Mm-hmm.
What are you going to draw? Oh, that's very nice. Is that looks like a donut stick.
It is.
Or a pickle. It could be a pickle.
Oh. But it's not. It's going to be a monster.
Oh, man, that's scary. Where's this? Oh, what's a smiling monster?
Mm-hmm. He's a nice one.
Oh, good. Can you make, it's kind of like a cone head. Can you make ears on him?
Nope.
Oh, okay.
I just can make ear dots on him.
Oh, ear dots. Oh, very nice. Oh, perfect. Does he have hair?
He's going to have hair right now.
Oh, I like that. Just kind of his forehead, huh?
And no wine.
Oh, what's that for?
It's for the feet.
Oh, there's his feet. Oh, very nice.
Mm-hmm. Now arms.
Oh. Oh, he's got arms coming out of his head? Cool.
Some could be like that.
Sometimes they're like that.
Huh.
Yeah. Oh. Very good. He's a scary monster.
That's not a...
I mean, sorry, that's right. I forgot. It's a good monster. Don't push too hard because you don't need to. You can use your finger too, you know.
Let me see.
Okay. What? Whoa. Can you draw your name?
Nope.
No? Okay. Alright, we gotta tell the students, say, see you later, alligator.
See where, alligator?